Hi Brittany, I thought I would make a video to explain these problems, so let's just go through them and then you can let me know what you still don't understand. So the first one says, determine the degree in the leading term of the following polynomial function. Now, so we have this, f of x equals x to the sixth or x to the 6 minus 1 squared. So we'd have x to the 6th minus 1 times x to the 6th, minus 1, times x cubed plus 3 cubed. Now, the good news is we don't have to multiply this all out. But what we want to think of is what would happen if we multiplied to get the leading term. So the leading term, if we have a polynomial, let me kind of give an example of that first. If we have something like 7x to the 5th minus 4x cubed minus 2x squared plus 1, just making up numbers, the leading term is always this, the very first term. And then the degree is the exponent on it. So the degree here would just be 5. Now, we don't have this in like what's called expanded form, where it's written out like, you know, all the way out like this. But how we would get this first term, since that's all we need, is by multiplying each of these first terms together. So we'd say, okay, what would happen if we had x to the 6th, x to the 6th, x cubed, x cubed, x cubed? And since these are all just x's, we would get x, and then we would add the exponents together. So 6 plus 6 plus 3 plus 3 plus 3 would be 12 plus 9, which is 21. So that's how the leading term is 21. And the degree is, the leading term is x to the 21st power. And the degree would just be 21. Okay. So this next part, it looks like you found f of 1 and f of negative 1. But we want to find f of 1 to the negative 6th. And this did say using synthetic division, so we would do 1 minus the square root of 6, and then we would put the exact same thing across the top. 1, 0 for x cubed, 0 for x squared, 0 for x minus 16. And now we're going to do synthetic division the same way. So we're going to bring down the 1, and then we're going to do 1 times 1 minus the square root of 6. So 1 times 1 minus the square root of 6. Well, distributing the 1 doesn't really do much. It would just still be 1 minus the square root of 6. Now we're adding 0 to that. So plus 0, we're not adding anything, so that would still just be 1 minus the square root of 6. Oops, I don't know why I wrote 3 there. Okay, so now we want to take 1 minus the square root of 6 times 1 minus the square root of 6. So I'm going to do that kind of off to the side. And we're going to FOIL this out. So foiling it, first we get 1. Outside we get minus square root of 6. Inside we get minus square root of 6. And last we get minus square root of 6 times minus square root of 6 gives us plus 6. So combining the like terms, we can add the 1 and the 6 would give us 7. And then we'd have minus 2 square root of 6 since we have 2 of them. So we would put that here. Now, again, adding 0 to that isn't going to do anything, so we'll have 7 minus 2 square root of 6. So we're going to multiply that by 1 minus the square root of 6. So 1 minus the square root of 6. Again, we'll do this off to the side. So it's foiling again, so our first terms will give us 7. The outside terms will give us minus 2 square root of 6. Inside terms will give us minus 7 square root of 6. And the last terms will give us minus times a minus, so it'll be a positive. We have 2, and then square root of 6 times square root of 6. So 2 times the square root of 6 times square root of 6 is 6. So that'll be 12. So 7 plus 12, we've got 19 minus 9 square root of 6. Okay, again there, adding 0 to it, we still get 19 minus 9 square root of 6. So we're now going to multiply that by 1 minus the square root of 6. And again, we're going to FOIL, so we'll have 19 minus 9 square root of 6 minus 19 square root of 6 plus we'll have 9 times square root of 6 times square root of 6 is 6. So this gives us 19 minus 25 square root of 6. Oh, sorry. Minus 9 minus 19 will give us 28 square root of 6 plus 54. So 19 plus 54 would be 73 minus 28 square root of 6. So that's what we're going to put here. Okay, so now we're adding, going down, so we do 73 minus 16, which would be 57 minus 28 square root of 6. Now, whenever you're doing this, we're taking the remainder when we're finding the function value. So that would be our answer. Okay. So this one says, given that the polynomial function has the given 0, find the other zeros. So this is saying, here's our function, x cubed minus 2x squared minus 11x plus 52, and it's telling us that one zero is negative 4. So we're going to do synthetic division with negative 4. So that will be 1, negative 4, negative 6, so 24, 13, negative 52, which will give us 0. So now we want to look at this, our quotient. And since this started as an x cubed, this will now be an x squared. So we'll have x squared minus 6x plus 13 equals 0. Now, to find the other zeros, we want to find the zeros of that. And this isn't going to factor. We're actually going to have to use the quadratic formula. You could also do completing the square if you like completing the square. So we'll do x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So 6 plus or minus, this will be 36 minus 52, which will be 16. Or negative 16 all over 2. So 6 plus or minus. Now the square root of negative 16, the negative gives us an I, and the square root of 16 is 4. And since both 6 and 4 are divisible with 2, we make this 3 plus or minus 2i. Divide the 2 out from both of them. So that gives us 3 plus 2i and 3 minus 2i as our other zeros. Okay, there was one other one I put up here. So this says, find a polynomial with real coefficients that has the given zeros. So it tells us that negative 1 is a 0. So that means we're going to have x, and then we do minus the 0. So x minus a negative 1. And 2 minus 5i. Now, if 2 minus 5i, since it has an I, we also have to have 2 plus 5i. Okay, so we're going to do x minus 2 minus 5i and x minus 2 plus 5i. Now we're going to simplify this a little bit before we multiply it out. So x minus a negative will be x plus 1. Then I'm going to distribute this negative before we multiply it out. So it'll be minus 2 plus 5i. And then here it'll be x minus 2 minus 5i. Now, to make this simpler in a minute, we're first going to FOIL out the two that are conjugates of each other. So we'll multiply the x all the way through. So that'll give us x squared minus 2x minus 5ix. Now we're going to multiply this negative 2 by each of them. So negative 2 times x will give us minus 2x. Negative 2 times negative 2 will give us plus 4. And negative 2 times negative 5i will give us plus 10i. Now we need to take this last 5i all the way through. So 5ix minus 10i, and then we're going to have a minus 5 times 5 will be 25i squared. So before we move on, we want to see what we can simplify. So this minus 5ix and this 5ix cancel each other out. This 10i and this negative 10i cancel each other out. And an I squared is the same as negative 1. So this whole term becomes a plus 25. So here we have x squared. We'd have minus 4x, just from these two terms. And then we have 4 plus 25, so plus 29. Okay, now we're going to multiply the x plus 1 times that. So we'll take the x by each of them. So I'll have x cubed minus 4x squared plus 29x. Then we'll take the 1. So x squared minus 4x plus 29. And when we simplify this, we get x cubed minus 3x squared plus 25x plus 29. And it was just asking you to fill in that number, which was 25. Okay, so whenever it says find this polynomial with given zeros, you're going to do x minus each of those numbers. Now, if you have something with an I or a square root, and only those two times, an I or a square root, you're also going to have to put the conjugate of that value in. Okay, so please let me know if you have any more questions, but I hope this clarified some of the things that you were having trouble with.